My name is Sanskar. Currently, I'm working in Flipkart as SG1. Previously, I've worked in Jaspe as SG, and I'm 22 grad from EC background. So today I'll be taking the session on the topic which is top 10 most algorithms, top 10 most important algorithms for coding interviews. So, and those are sorting algorithms, searching, string algorithms, divide and conquer, recursion and backtracking, greedy algorithms, dynamic programming, tree related algos, and graph algorithms, and sliding window. I've noted that down. You can pause and go through them. So, I'll be talking about these algorithms in a very quick at first, and then we'll be seeing that how we can tackle the kind of questions regarding those algorithms and how to identify that which question can be solved with what type of algorithm. Okay, so if I take, for example, for sorting algorithms, if I take sorting algorithms arrange elements in a specific order. For example, either ascending or descending uh, in an array, for example. So this is what sorting algorithms look like, and there are some famous sorting algorithms like bubble sort, instance sort, etc. We'll be looking at that later on. And the second are the searching algorithms. For example, these they're like two famous algorithms like linear search and binary search. So we use these algorithms for uh, to search any particular element in either list or array, whatever the data structure there is. So this is what basically searching algorithms is, and they are very helpful. Apart from that, there are string algorithms, and string algorithms basically deal with manipulating and analyzing strings. And there are different kind of patterns which are there in this string algorithms that we'll be looking later on. Apart from that, there is fourth one is the divide and conquer. So divide and conquer is basically breaks a bigger problem into sub problem and solve them independently and combines their solution to make the original solution which was there. Okay, so this is what divide and conquer looks like. Apart from that, there are recursion and backtracking. So recursion basically is something similar to divide and conquer, but here what we do is we basically call the same function inside itself by passing a smaller value as a parameter in the same function, and we use the smaller sub problem answer for our original problem. So this is what recursion is look like. And backtracking is like we are exploring different possibilities of a solution, and in that we are doing some calculations and we undo it at the last of our function. So this is what the difference between recursion and backtracking. Apart from that, there are this is the greedy algorithms. So greedy algorithms is basically making they make the optimal choices at each stage with the hope of finding a global optimum solution. So this is what greedy algorithms look like, and we'll be exploring that what kind of problems in greedy comes later on. Apart from that, there is this dynamic programming. So we are like, as we talked about recursion, so in recursion sometimes what happens is we are calling the same function for different times at for the same value for the same parameter. So now there are like sub problems which are overlapping. We are calling the same function again and again. So now here the dp comes under the picture. So in this what we do, we use the concept of memorization. And memorization is basically we are storing we are storing the answer of an existing problem, and instead of recalculating it again, we are using the same function from our stored place or stored source, whatever we are storing. So this is what the dp is basically dp is like advanced level of recursion in which we use like we just apply the abstraction of memorization, and we can also convert our solution into the iterative way also in the dp. So that we will see. Apart from that, there are tree related algorithms. So tree related algorithms basically they are like just traversing the tree and doing some calculation, and there are different type of algorithms to explore the tree or to traverse the tree, like pre-order, in order, and these are all there, which we will see later on. And apart from that, the graph algorithms, and graph algorithms are majorly depend on two algorithms. Like one is the BFS, which is called as breadth first search, and another one is called as DFS, which is called as depth first search. Okay. And the last one is sliding window. So sliding window, as a name says, ki we are making a window and we are sliding it either on a array or a string, and we are doing some calculation. So this is what the quick intro of each of the algorithms. Now we will see in depth that how we can identify our problems, or what are the use cases, and how you can explore these things, and what are the basics you need to know. So let's focus on the famous sorting algorithms. I've noted it down to save the time. So the first one is the bubble sort, and bubble sort is basically takes the O(n) square time complexity. You can explore this. Apart from that, there are instances sort, selection sort, with the same time complexity. Now if you are doing these sorting algorithms, or explaining them to interviewer, so he might ask you to optimize it. Okay, because O(n) square is not usually a good time complexity. So to do that, what you can do, you can also learn these three algorithms, which are merge sort, quick sort, and heap sort. These are very famous algorithms. So merge sort, quick sort use the concept of recursion also, that we will see, and here the concept of divide and conquer also comes, that we will also see how you can use it. And the use case of these sorting algorithms comes under these type of questions, like two pointer, three pointer, these kind of questions. So what happens, ki you have to maintain a two pointer kind of approach. For example, if I say there is one array, and there are a b c. Let's not take abc, let's take some integer. For example, 3, 2, 1, 5, 7. Now if you want to get a pair of some, for example 3. Okay, you want to find out. Now what you can do, you can apply the sorting algorithms. After sorting, your array will look like 1, 2, 3, 5, 7. And after that, what you can do, you can maintain two pointers, one at the zeroth index, one at the last index, and you can keep iterating the what you can do, you can keep iterating the loop while I is less than equal to j, and you can check the sum of those index, and you can find out that a pair of for example, we want to find the 3, then this j will keep come here at this level, and you will get to know that 1 comma 2 is a pair which sums up to 3. So that's how you can find out the pair. So this is what the use case of sorting algorithms. Apart from that, there is one searching algorithm, as I told, that is binary search, that we will see what it does. So in that also, searching will help you. And apart from that, there are some other famous questions, like kth smallest or largest element in the array. So what you can do, you can just sort the array, and you can just easily find out the uh, kth smallest or largest element of an array. And similarly, you can find the kth smallest and largest sum also. So this is what you need to learn about sorting algorithm. These are just the basics. Now you will be using this concept in higher hard problems or higher concepts. So this is just the basics which you need to know. And apart from that, let's go to the second algorithms, which are searching algorithms. Now there are mainly two searching algorithms which you will be using. One is the linear search, and another one is the binary search. For linear search, the time complexity is O of n. Now again, interviewer will be always looking for an optimized approach. So now you have to learn the optimized approach as well. For that, you can explore binary search. Binary search basically it basically sort the so there is one condition on binary search. It basically applies on the sorted array, which I already told you that by in the previous use case of searching algorithms, that here you will be using this uh, searching algorithm in binary search. So what it does, key, it basically neglects the half part of the array which are not useful for your case. So this is what the binary search is, and it basically keep neglecting half part of the array, and it will conclude to the answer of your which you wanted to find. So this is what the binary search is. You can explore it later. uh, Apart from that, the use case of these searching algorithms are very basic, is the finding an element of unnecessary conditions. Like there are there are some requirements. On the basis of those requirements you want to find an element. So the basic thing will be, you will be applying linear search. Now as usual, interview will be asking you to optimize it. Now you need to look into the binary search approach, that how you can apply, and it will be optimized version of the linear search. So this is what you can explore. And apart from that, this binary search will be helpful in BST also. The same logic, BST is basically nothing but the binary search tree. So the use case will be there. I'll be telling in the tree related algorithms. So this is what you need to keep in mind, that the use case of these two algorithms, like use case of this binary search and the use case of these two in the finding an element of some different specific requirement. So this is what the uh, searching algorithms look like. Apart from that, let's move on to the third one, which is known as like string algorithms. So what you need to learn about these string algorithms is that whenever you will be getting a question, you will be need to mostly you will be need to manipulate the strings, and you have to analyze on the basis of the requirements. You need to analyze and manipulate these strings. So now, for example, if I take that, what kind of patterns you will see in these string algorithms, there are very famous called anagrams, isomorphic. These are the very famous patterns which you will be seeing. So now, for example, what are anagrams? Anagrams is basically, for example, listen and silent. So we have just reshuffle the characters, and the same amount of characters are there. So this is what anagram look like, and listen and silent are anagram to each other. Similarly, if I take example of isomorphic, isomorphic is basically you are mapping a similar kind of alphabet with same number of frequency. For example, ag and add. E you can map to A, and double G you can map to double D. So this is what isomorphic strings are. And these string manipulation question can also be comes under recursion also, that we will see. So this is what the string algorithms. You need to identify these patterns, that anagrams, isomorphic, and there you need to solve these string algorithms. So this is what majorly you have to learn about the string algorithms. Now if I move to next topic, which is divide and conquer. So divide and conquer, as I told earlier, that a problem which is broken down into sub problems and that are solved independently, and the solution is combined to prepare original solutions, right? So this is what I told earlier. So for example, if there is a bigger array, and now what you're doing, you are dividing this particular array, and you are solving this independently. Again you are dividing this array into two sub problems, and you are solving them independently. Again you are breaking those arrays into sub arrays, and you are calculating those independently, and you are using their solution to combine the original solution. So this is what the divide and conquer basically looks like. uh, so in the binary search also, we saw that half part of the array is neglecting. So we are like dividing and conquering. So we are dividing the portion, and we are saying yeah, this is my useful part. So this is what divide and conquer looks like. And the concept of divide and conquer you will be seeing in merge sort, quick sort, binary search. Binary search I already told. So merge sort is basically a sorting algorithms where you will be using the array. You will be dividing it, and you will be reshuffling the elements to its rightmost place, where you need to put the element in a specific order. For example, if you're sorting in an ascending order, then you will be putting the smallest elements in the left side, and you will be keeping the larger elements on the right side. So that's what the divide and conquer will look like. If you will explore this merge sort, then you will get to know about the divide and conquer algorithms. So this is what divide and conquer algorithms look like, and these are the example where you can learn this divide and conquer concept, and you will be able to see in these algorithms. So you can explore them. Okay. Apart from that, let's go to the next, which is recursion and backtracking. So recursion is nothing but the breaking a bigger problem into smaller problems and using the same function inside it by passing a smaller parameter value. For example, if I take example, I'll take example of factorial, which I already written here. So the factorial example, if you want to calculate the factorial of 5, okay. So now what you will do, you will just say to the recursive function that I am saying ki I'll be So factorial 5 is factorial of 5 into factorial of 4. Okay, and factorial of 4 will be 4 into factorial of 3. So now you don't need to keep doing all these things. What you can do, you can do this first step. Now you will tell your recursive function that give me the answer of this, and whatever is the answer of this, you will just multiply it into your 5, and that will be the finalized answer. So what you are doing, you are just doing a first step of your calculation, and the remaining you are saying to your recursive solution that, hey recursive solution, give me the remaining solution, and now I'll use that and I'll conclude to my answer. So the structure of recursive functions looks like is, for example, this is my function and this is the parameter value. Now the first thing will be, there is a base case. Okay, in the factorial case, for example, the base case will be if n equal to 0, return 1, because factorial of 0 is the 1. You need to define the base case because there will be a recursive stack overflow which we don't want. There should be a edge case, or sorry, your base case, which from where if the value of n reaches, it should be written from there. So that's what the whole logic of writing base case. And then next step, what you can do, you can say ki small answer, hey my recursive function, give me the small answer of this n minus 1 value. That is, for example, for 5, give me the answer of 4. And what I'll do in my finalized answer, I'll multiply this 5 into your smaller answer, and I'll return the final answer, and this is my actual answer. So this is what the recursive function look like. Okay, yeah. So as I was saying, that you need to, the structure of recursive function will be like ki, you need to identify the base case, do calculation for one case, and the answer remaining will be done by the recursion. Okay, you tell the recursive function ki, hey give me the remaining answer, and I'll use that in my finalized answer and I'll return it. So that's what you need to do, and you need to write the recursive case. In our case, that here this will be a recursive case which we write. So that's what the whole recursive algorithm look like. So now the difference between the recursion and the backtracking is key. In backtracking, you are exploring different possibilities like recursion, because recursion will be exploring different possibility. For example, for if I take example of factorial, I'm just taking, it will not come under the backtracking concept, but I'm just taking, for example, if we are doing exploring different possibility like factorial of 4, factorial of 3, factorial of 2, factorial of 1. So these are different possibilities which we are exploring through this recursive function. Now for example, if I take, this is my recursive function. Okay, here I wrote some base case, this is my recursive case, and now I am returning my answer from here. Now if you're writing, if you're doing some calculation before doing your recursive case, for example, if you've done some calculation here, now you will be undoing your calculation before returning your answers, so that you can explore each and every possibility. You have to explore each and every possibility, so you will be undoing some calculation which you have done, so that your next iteration or the next possibility will not affect from your previous calculation. So that's what the difference between the backtracking and the recursive function. Okay, I hope you understood the like difference between the uh, recursion and the backtracking. So that's the same thing which I just wrote, but just undoing your calculation at the last, which you have done at first, at the starting of your function. So example of recursion will be the factorial, Fibonacci, and this recursion is the very important concept which you need to learn, because if you're not learning recursion, then it will affect in your dynamic programming, it will affect in your trees, because every tree question can be solved using recursion. So this is what the example of recursion. And apart from that, there is Radena maze, which is a very famous example of backtracking, because you will be undoing, for example, there is a maze, okay, and you are exploring different possibilities. So now if you're not able to reach at the end, you will be undoing this whole thing, and you're exploring some different possibility. So this is what the concept of backtracking is. And the famous example, you can explore Retina maze, and the knights k knights problem is there. These are very famous problems which you can explore. Okay, so let's move to the next algorithm. So next one are the greedy algorithms. Greedy algorithms are nothing but they make the locally optimal choices. Yeah, so they make the locally optimal choices at each stage with hope of finding optimal solution. The goal of using the greedy algorithms is you want to find the optimal solution by hook or crook. So in most of the cases, we will be there will be the concept of sorting algorithms will be come here will be coming here. You will be sorting most of the cases. You will be doing sorting, and that will help you in the greedy algorithms. Okay, so the famous if I take the famous example, then there is a maximum meeting in one room. So and there is one job sequencing problem here. Most of the time, yeah, I've written down here, most of the time sorting will be used to get the optimal solution. So you need to learn sorting before jumping to the greedy algorithms. That will be helpful for you. So this is one of the famous question. It has been asked to me in 2 or 3 interviews. You can explore this maximum meetings in room. So yeah, grading algorithms are one of the important topics which you need to learn. Oh, okay, and there are like some advanced questions also which you can explore. Like sorry, there is one called fractional knapsack. Knapsack problem is one of the famous problem in DP dynamic programming. Now there is one advanced version of that is called fractional knapsack that you will be able to solve once you know the greedy concepts. Okay. Now let's move down to DP. DP is one of the scariest topic people thinks, but according to me, it is not that scary. But the whole logic is ki you need to do as much as practice you can do. Okay. So now DP is just like a abstraction over recursive function. Here we will be using the concept of memorization, and we will memorize. For example, if I take example of Fibonacci, so in Fibonacci there will be multiple overlapping sub problems. So let's take one example of Fibonacci. So in Fibonacci, for example, the series is 0, 1, 2, 3, 5. Fibonacci is nothing but the sum of the last two elements. Okay, 8. So now every time there will be calls for n minus 1 and n minus 2. Okay, and there will be different cases. There will be multiple overlapping sub problems for the same case. Like uh, there will be multiple overlapping sub problems which will be there. So now to avoid that, what we do, we use one array. And what we do key, for example, if this is my recursive function, there is the base case. So the structure of this DP question will be look like, function will be look like. Here you will be writing your base case, and here you will be putting a check key if your array or the DP array is the same. For example, here is n. So if n not equal to empty or minus 1, for example, what with whatever value you are initializing your DP array, you will check. If it is not, then you have to return the answer from this array only. So you don't need to go further. Okay, now the same recursive case will be there, and you will be using this recursive case, and you will be doing it like using this recursive case answer into your final answer, and you will be returning it. And before returning the final answer, what you do, you save this answer at the same value of n in your DP array, and now you return this answer or DP array. So you are, and the DP array will be nothing but you will be initializing it with minus 1 into the length of n, whatever is the value of given n to you. So this is what the structure of DP array, sorry, DP function will be look like. Okay, I hope you got the difference between the recursion and DP. DP is nothing but just we are using the same value, sorry, the same function as recursive, and we are just putting two extra steps in that recursive function. That is, one is this, we are checking ki either the value is already present in our DP array or not, or we are saving this function. So and we are saving this value. Let me just, yeah. So we are just saving this answer value in our DP array, and we are just storing it, and then we are returning. And so these two extra steps has been added in the recursive function. Okay, and now you can furtherly iterate, convert this recursive solution into the iterative on the with the help of this DP array only, because recursion is nothing but basically it is using stack as a memory. Now what you've done, you have just converted into the you are using the same array, and now you can use this array, and you can use this array as a storage value, and you can keep using those same answers in your iterative solution. So this is what the majorly difference between the recursive and iterative thing. Okay, so yeah, this is the most like this is what the dynamic programming algorithms look like. And now there are some very famous like Fibonacci you can explore, and stairs problem you can explore. And now there are some very advanced DP algorithms like DP questions like longest increasing subsequence, longest common subsequence, that you will get to that you will be able to know once you do these basic questions and learn the concept of dynamic programming. Then only you will be able to know. Okay, so this is what the dynamic programming algorithms look like. Now if we move to the tree related algorithms, as I said, key tree related algorithms, like every problem of tree can be solved using recursion. So recursion should be the base of your coding. Okay, and this is one of the like most important and sometimes scary also. So you don't need to worry about that. You just need to do as much as practice you can do. Okay, so each and every problem of this recursion sorry tree can be solved using recursion. Now if I talk about the traversal algorithms of tree, so now there are five, there are not four, there are not three, there are five algorithms which you need to learn. First is the pre-order, another one is the post order, third one is the in order, fourth one is the level order. These all are recursive. Now this one is iterative. Here you will be using the concept of queue. And now this is one of the most important. This has been asked to me in many interviews, and this has been asked to some people in the Google interviews also. This has been asked to me, one of my friend who gave interview in Google. So this is one of the important algorithm which you need to explore. Okay, so these you can explore. Now if I talk about the types of tree which are there, so you need to learn. First one is the binary tree. There will be a node, and at most it can have two nodes. So these are binary, 0 1. Okay, so either it can have 0, it can has 1, or it can has 2. Okay, so this is the binary tree. Now BST is like a binary tree, but it will be like for example, if this is a binary tree, there are some subtree also. Now for this root node, all the left subtree nodes should be less than so value of those left subnodes tree should be less than the root node value, and the right side should be greater than equal to. So this is what the concept of BST. You need to learn both binary and BST, because they are the main important topics in the trees. Apart from that, you need to explore NRA tree, because in one hackathon I have been asked a question on this NRA tree. So you need to explore this as well. Now let's move to the uh, graph algorithms. So now the graph algorithms has been they are totally dependent on two algorithms which are BFS and DFS. uh, BFS is basically acronym for breadth for search, and DFS for depth for search. So you need to explore both of these algorithms, and on like these two algorithms can solve most of the graph algorithms. Now if I talk about some advanced graph algorithms which you need to learn, for example, Dijkstra is one of the famous graph algorithms which is used to find the shortest nodes. Another one is their Kruskal's prims for the minimum spanning tree. So this has been right. I've noted that down. Minimum MST is nothing but the minimum spanning tree. And you need to learn these two algorithms for MST. They are very important. And apart from that, there is one more, Bellman Ford. You can explore these famous algorithms. I have noted it down. Apart from that, there are some cycle detection algorithms also are there which are very famous in this, that they can be solved using BFS and DFS. Now let's talk about more BFS and DFS. BFS is basically a iterative kind of approach in which we use the queue and we use keep iterating over the nodes of different graphs. And in the DFS, what we do, we just basically use the recursion. So yeah, as I already told before, recursion is one of the important concept that you need to learn. So this is what the majorly graph algorithms will be looking like. You need to explore BFS and DFS, and you need to just keep solving their problems as you need to keep solving as much as you can do, because the more you practice the more will be beneficial for you. Now let's move down to the last topic, which is the sliding window. So now here, as the name suggests, that here we will be maintaining either a fixed or a variable size window over an array list or a string. So it depends totally on the requirement, that on what kind of data structure, either array or either string, we are applying this sliding window approach. So this will, here you just need to maintain a sliding window and you just need to doing some calculation on that. Now I'll note down some examples for you which you can explore, and after you will explore you will get to know ki how I can approach this sliding window kind of questions. Okay, for example, there is one famous question called maximum sum array of size k. Here they have already defined size k. So this will be a fixed window. You need to keep sliding that fixed window of size k, and you need to find the maximum sub array. So this is what how will be the maximum. This is how will the fixed window fixed sliding window question look like. So, okay, now if I talk about the variable or the dynamic sliding window question, so there is one called length of smallest sub array with some k, some greater than equal to k. So some you need to find the smallest subarray. So here smallest subarray length could be vary. Okay, so that will be your sliding window. For example, you will be keeping a window and you will be sliding it, and you will be keep making it small and small. So that's how your window is also keep window is dynamic. So you need to find the sum which is greater than equal to k in the smallest subarray, and you need to find the length. So this is what the variable sliding window question look like. So now there are some more famous questions which I noted down. Longest substring without repeating characters. This question has been asked to me in many interviews. And there is one more, minimum size array sum. You can explore these. And now if I talk about that, how will be the structure of this sliding window algorithms look like? For example, there is one array 1 3 5 8 9 7 6. Now, for example, if they say key, for example, if I take the find maximum sum array of size k, so size k will be, for example, if I'm taking size k equal to 3, now in this size 3, I will be maintaining a window of size 3, and I will be keeping this sum as, for example, for this window, the sum will be 9. Now I'll again move my window. Now I'll check the sum key 3 5 8 16. Again I'll move my window 9 8 17 and 5 22. Again I'll move my window 16 and 6 22 again. Again I'll move my window. Yeah, I cannot move further because then the size will be 2. So among all these different subarrays of size k, the maximum value is 2. So that's what you need to find out. So that's how the sliding window question will look like. So you can explore these famous questions, and you can also explore these questions from Google also. So I've just noted down these basics to tell you that how this algorithms look like. So this is all about these top 10 algorithms, which will be very much important for your interviews. I hope I was able to explain you that how you can explore all these, and how you can get the idea about how you can solve, how you need to solve these different algorithms, how you need to identify. So that's it from my side. I hope you enjoyed the session. Thank you so much.